NCERT presents audiobook of Geography for Class 8 entitled Resource and Development. Lesson 3 Mineral and Power Resources. Giri was visiting Sukant in his native place near Dhanbad. Giri was amazed to see that large areas were black. Sukant, why is this place so black and dusty? She asked. This is because of the coal mines nearby. Do you see the trucks? They are carrying the mineral coal, replied Sukant. What are minerals? Asked Giri. Sukant replied, have you ever seen a baker baking biscuits? The flour, milk, sugar and sometimes eggs are mixed together. While eating the baked biscuits, can you see the ingredients separately? Just as in the biscuits, there are a number of things that you cannot see. Rocks on this earth have several materials called minerals mixed in them. These minerals are scattered throughout the earth's rocky crust. On the top left, there is a figure 3.1 which shows loading of a truck in a coal mine. A naturally occurring substance that has a definite chemical composition is a mineral. Minerals are not evenly distributed over space. They are concentrated in a particular area or rock formations. Some minerals are found in areas which are not easily accessible, such as Arctic Ocean bed and Antarctica. Minerals are formed in different types of geological environments under varying conditions. They are created by natural processes without any human interference. They can be identified on the basis of their physical properties such as color, density, hardness, and chemical property such as solubility. At the bottom, there is a red box which reads, do you know? The salt in your food and graphite in your pencil are also minerals. Page number 23. Types of minerals. There are over 3,000 different minerals. On the basis of composition, minerals are classified mainly as metallic and non-metallic minerals. On page, there is a yellow colored box given, in which there is a drop-down diagram mentioned. This diagram shows the classification of minerals. The two classified minerals are metallic and non-metallic. In this diagram, further, metallic is classified into two minerals. One is ferrous, other is non-ferrous. This was figure number 3.2 titled Classification of Minerals. There is a red box on the right side which reads, do you know? A rock is an aggregate of one or more minerals, but without definite composition of constituent of mineral. Rocks from which minerals are mined are known as ores. Although more than 2,800 types of minerals have been identified, only about 100 are considered ore minerals. Metallic minerals contain metal in raw form. Metals are hard substances that conduct heat and electricity and have a characteristic luster or shine. Iron ore, bauxite, manganese ore are some examples. Metallic minerals may be ferrous or non-ferrous. Ferrous minerals like iron ore, manganese, and chromides contain iron. A non-ferrous mineral does not contain iron but may contain some other metal such as gold, silver, copper, and lead. Non-metallic minerals do not contain metals. Limestone, mica, and gypsum are examples of such minerals. The mineral fuels like coal and petroleum are also non-metallic minerals. Minerals can be extracted by mining, drilling, or quarrying. In the middle of page, there is a pink colored box given, in which there is a drop-down diagram mentioned. This diagram shows the different methods of extraction of minerals. The three methods of extraction of minerals mentioned here in this drop-down diagram are mining, drilling, quarrying. In this diagram, further, two different methods of mining is mentioned are open cast mining and shaft mining. This was figure number 3.3 titled Extraction of Minerals. The process of taking out minerals from rocks buried under the earth's surface is called mining. Minerals that lie at shallow depths are taken out by removing the surface layer. This is known as open cast mining. Deep bores called shafts have to be made to reach mineral deposits that lie at great depths. This is called shaft mining. Petroleum and natural gas occur far below the earth's surface. Deep wells are bored to take them out. This is called drilling. Minerals that lie near the surface are simply dug out by the process known as quarrying. At the bottom right, there is figure 3.4, which shows offshore drilling of oil. Page number 24. Distribution of minerals. Minerals occur in different types of rocks. Some are found in igneous rocks, some in metamorphic rocks, while others occur in sedimentary rocks. Generally, metallic minerals are found in igneous and metamorphic rock formations that form large plateaus. Iron ore in North Sweden, copper and nickel deposits in Ontario, Canada, iron, nickel, chromides, and platinum in South Africa are examples of minerals found in igneous and metamorphic rocks. Sedimentary rock formations of plains and young-fold mountains contain non-metallic minerals like limestone. Limestone deposits of Caucasus region of France, manganese deposits of Georgia and Ukraine, and phosphate beds of Algeria are some examples. Mineral fuels such as coal and petroleum are also found in the sedimentary strata. At the top left side, there is a red table which reads, "Do you know? You can always tell if a rock contains copper because then the rock looks blue in color." Asia. China and India have large iron ore deposits. The continent produces more than half of the world's tin. At the bottom of page, there is figure number 3.5, which has world map, and map shows distribution of iron, copper, and bauxite. Page number 25. China Malaysia, and Indonesia are among the world's leading tin producers. China also leads in production of lead, antimony, and tungsten. Asia also has deposits of manganese, bauxite, nickel, zinc, and copper. Europe. Europe is the leading producer of iron ore in the world. The countries with large deposits of iron ore are Russia, Ukraine, Sweden, and France. Minerals deposits of copper, lead, zinc, manganese, and nickel are found in Eastern Europe and European Russia. On the right side, there is a red box which reads, "Do you know? Switzerland has no known mineral deposit in it." There is another yellow color box which reads, "Let's do." Identify the Canadian Shield, the Appalachians, Western Cordilleras, and Lake Superior with the help of an atlas. North America. The mineral deposits in North America are located in three zones: the Canadian region north of the Great Lakes, the Appalachian region, and the mountain ranges of the west. Iron ore, nickel, gold, uranium, and copper are mined in the Canadian Shield region. Coal in the Appalachian region. Western Cordilleras have vast deposits of copper, lead, zinc, gold, and silver. At the bottom of page there is figure number 3.6, which has world map, and it shows distribution of mineral, oil, and coal. Page number 26. South America. Brazil is the largest producer of high-grade iron ore in the world. Chile and Peru are leading producers of copper. Brazil and Bolivia are among the world's largest producers of tin. South America also has large deposits of gold, silver, zinc, chromium, manganese, bauxite, mica, platinum, asbestos, and diamond. Mineral oil is found in Venezuela, Argentina, Chile, Peru, and Colombia. Africa. Africa is rich in mineral resources. It is the world's largest producer of diamonds, gold, and platinum. South Africa, Zimbabwe, and Zaire produce a large portion of the world's gold. The other minerals found in Africa are copper, iron ore, chromium, uranium, cobalt, and bauxite. Oil is found in Nigeria, Libya, and Angola. There is a red box on the left side which reads, "Do you know? A green diamond is the rarest diamond." The oldest rocks in the world are in Western Australia. They date from 4,300 million years ago, only 300 million years after the Earth was formed. Australia. Australia is the largest producer of bauxite in the world. It is a leading producer of gold, diamond, iron ore, tin, and nickel. It is also rich in copper, lead, zinc, and manganese. Kalgoorlie and Coolgardie areas of Western Australia have the largest deposits of gold. Antarctica. The geology of Antarctica is sufficiently well known to predict the existence of a variety of mineral deposits, some probably large. significant size of deposits of coal in the Transantarctic Mountains and iron near the Prince Charles Mountains of East Antarctica is forecasted. Iron ore, gold, silver, and oil are also present in commercial quantities. Use of minerals. Minerals are used in many industries. Minerals which are used for gems are usually hard. These are then set in various styles for jewelry. Copper is another metal used in everything from coins to pipes. Silicon used in the computer industry is obtained from quartz. Aluminium obtained from its ore, bauxite, is used in automobiles and airplanes, bottling industry, buildings, and even in kitchen cookware. At the bottom left side, there is a green box which reads, "Let's do." List uses of any 5 minerals. Number 27. Conservation of minerals. Minerals are non-renewable resource. It takes thousands of years for the formation and concentration of minerals. The rate of formation is much smaller than the rate at which the humans consume these minerals. It is necessary to reduce wastage in the process of mining. Recycling of metals is another way in which the mineral resources can be conserved. On the top right side, there is a figure given, titled Think and Act. This figure shows 3 R's for minerals: reuse, reduce, recycle. Power resources. Sunny's mother begins her day by switching on the geyser. She irons Sunny's school uniform before waking him up. She then rushes to the kitchen to prepare a glass of orange juice for him in the blender. "Sunny, have you finished taking bath? Come and have your breakfast," calls out mother while preparing breakfast on the gas stove for Sunny. While going to school, Sunny forgets to switch off lights and fans. When mother switches them off, she thinks that life in the cities may be more comfortable, but its dependency on more and more gadgets, all of which consume energy, has led to a wide gap between the demand and the supply. With the advent of science and technology, the lifestyles are changing very fast. Power or energy plays a vital role in our lives. We also need power for industry, agriculture, transport, communication, and defense. Power resources may be broadly categorized as conventional and non-conventional resources. On the right side, there is figure number 3.7, which shows national power grid to supply electricity. Conventional sources. Conventional sources of energy are those which have been in common use for a long time. Firewood and fossil fuels are the 2 main conventional energy sources. Firewood. It is widely used for cooking and heating. In our country, more than 50% of the energy used by villagers come from firewood. Remains of plants and animals which were buried under the earth for millions of years got converted by the heat and pressure into fossil fuels. Fossil fuel such as coal, petroleum, and natural gas are the main sources of conventional energy. The reserves of these minerals are limited The rate at which the growing world population is consuming them is far greater than the rate of their formation. So, these are likely to be exhausted soon. On page number 28, there is a diagram given showcasing the advantages and disadvantages of different sources of energy. In the first part of the diagram, advantages of oil and natural gas are given. The advantages of oil are: number 1, easier to transport, tankers. Number 2, basis of petrochemical industry. The advantages of natural gas mentioned here are: number 1, easier to transport, pipelines. Number 2, cleaner than oil and coal. Number 3, cheaper than oil. In the same part of the diagram, disadvantages of conventional sources of energy mentioned are: number 1, depletion of oxygen due to oil spillage and gas leakage. Number 2, pollutants released caused acid rain. Number 3, exploration of new fuel is not easy. In the next part of the diagram, 2 conventional sources are mentioned. One is firewood and other is coal. The advantages of firewood are: number 1, easy access. Number 2, provides energy to a large number of people. The disadvantages of firewood are: number 1, collection is time consuming. Number 2, polluting. Number 3, promoting greenhouse effect. Number 4, deforestation. The advantages of coal are: number 1, extensively available. Number 2, efficient conversion to electricity. Disadvantages of coal are: number 1, polluting source. Number 2, bulky to transport. In the last part of the diagram, the advantages and disadvantages of hydropower, which is also a conventional source of energy, is mentioned. The advantages of hydropower are: number 1, non-polluting. Number 2, promotes irrigation and fishing. Number 3, cheap. Disadvantages of hydropower are: number 1, displacement of local community. Number 2, inundates low-lying regions. Number 3, expensive to set up. This was figure number 3.8, titled Conventional Sources of Energy. On the left side, there is a figure 3.9 which shows a woman carrying firewood in northeast India. Coal. This is the most abundantly found fossil fuel. It is used as a domestic fuel in industries such as iron and steel, steam engines, and to generate electricity. Electricity from coal is called thermal power. The coal which we are using today was formed millions of years ago when giant ferns and swamps got buried under the layers of earth. Coal is therefore referred to as buried sunshine. The leading coal producers of the world are China, USA, Germany, Russia, South Africa, and France. The coal producing areas of India are Raniganj, Jharia, Dhanbad, and Bokaro in Jharkhand. On the bottom left side, there is a figure 3.10 which shows a view of a thermal power station. Page number 29. Petroleum. The petrol that keeps your car running, as well as the oil that keeps your cycle from squeaking. Both begin as a thick black liquid called petroleum. It is found between the layers of rocks and is drilled from oil fields located in offshore and coastal areas. This is then sent to refineries which process the crude oil and produce a variety of products like diesel, petrol, kerosene, wax, plastics, and lubricants. Petroleum and its derivatives are called black gold as they are very valuable. On the left side of page number 8, there is figure number 3.11, which shows crude oil. The chief petroleum producing countries are Iran, Iraq, Saudi Arabia, and Qatar. The other major producers are USA, Russia, Venezuela, and Algeria. The leading producers in India are Digboi in Assam, Bombay High in Mumbai, and the deltas of Krishna and Godavari rivers. On the top right side, there is an orange box which reads word origin. The word petroleum is derived from Latin words petra, meaning rock, oleum, meaning oil. So, petroleum means rock oil. Natural gas. Natural gas is found with petroleum deposits and is released when crude oil is brought to the surface. It can be used as a domestic and industrial fuel. Russia, Norway, UK, and the Netherlands are the major producers of natural gas. In India, Jaisalmer, Krishna Godavari Delta, Tripura, and some areas offshore in Mumbai have natural gas resources. Very few countries in the world have sufficient natural gas reserves of their own. On the right side, there is a red box which reads, do you know? Compressed natural gas (CNG) is a popular eco-friendly automobile fuel as it causes less pollution than petroleum and diesel. The sharp increase in our consumption of fossil fuels has led to their depletion at an alarming rate. The toxic pollutants released from burning these fuels are also a cause for concern. Unchecked burning of fossil fuel is like an unchecked dripping tap which will eventually run dry. This has led to the tapping of various non-conventional sources of energy that are cleaner alternatives to fossil fuels. Page number 30. Tidal power. Rainwater or river water stored in dams is made to fall from heights. The falling water flows through pipes inside the dam over turbine blades placed at the bottom of the dam. The moving blades then turn the generator to produce electricity. This is called hydroelectricity. The water discharged after the generation of electricity is used for irrigation. 1/4 of the world's electricity is produced by tidal power. The leading producers of tidal power in the world are Paraguay, Norway, Brazil, and China. Some important tidal power stations in India are Bhakra Nangal, Gandhi Sagar, Nagarjun Sagar, and Damodar Valley projects. On the top left side, there is a red box which reads, do you know? Norway was the first country in the world to develop hydroelectricity. There is another red box which reads, do you know? The site of the world's first solar and wind-powered bus shelter is in Scotland. In the middle of page, there is figure number 3.12, which shows tidal power. Non-conventional sources of energy. The increasing use of fossil fuels is leading to its shortage. It is estimated that if the present rate of consumption continues, the reserves of these fuel will get exhausted. Moreover, their use also causes environmental pollution. Therefore, there is need for using non-conventional sources such as solar energy, wind energy, tidal energy, which are renewable. On the bottom left side, there is figure number 3.13, which shows Salal Hydroelectric Project, Jammu and Kashmir. Solar energy. Sun's heat and light energy can be felt by us every day. Solar energy trapped from the sun can be used in solar cells to produce electricity. Many of these cells are joined into solar panels to generate power of heating and lighting purpose. Page number 31. The technology of utilizing solar energy benefits a lot of tropical countries that are blessed with abundant sunshine. Solar energy is also used in solar heaters, solar cookers, solar dryers, besides being used for community lighting and traffic signals. On page number 31, there is a diagram given showcasing the advantages and disadvantages of non-conventional sources of energy. First part of the diagram shows the advantages and disadvantages of wind energy. The advantages of wind energy are: number 1, non-polluting; number 2, low-cost production of electricity once set up; number 3, safe and clean. The disadvantages of wind energy are: number 1, noise pollution; number 2, windmills costly to set up; number 3, disturbs radio and TV reception; number 4, harmful to birds. In the next part of the diagram, two non-conventional sources of energy are mentioned. One is solar energy and other is tidal energy. The advantages of solar energy are: number 1, inexhaustible; number 2, non-polluting. The disadvantages of solar energy are: number 1, expensive; number 2, diffuse source, so gets wasted. The advantages of tidal energy are: number 1, non-polluting; number 2, inexhaustible. The disadvantages of tidal energy are: number 1, destroys wildlife habitat; number 2, difficult to harness. In the next part of the diagram, two non-conventional sources are mentioned. One is nuclear energy and other is biogas. The advantages of nuclear energy are: number 1, emits large amount of energy. The disadvantages of nuclear energy are: number 1, generates radioactive wastes; number 2, expensive. The advantages of biogas are: number 1, low cost; number 2, easy to operate; number 3, makes use of bio-waste. The disadvantages of biogas are: number 1, causes greenhouse effect. The last part of the diagram mentions the advantages and disadvantages of geothermal energy. The advantages of geothermal energy are: number 1, clean, eco-friendly and always available. The disadvantages of geothermal energy are: number 1, located far away from cities and so costly to transport the electricity. This was figure number 3.14, titled Non-Conventional Sources of Energy. On the right side, there is figure number 3.15, which shows solar panels to trap solar energy. Wind energy. Wind is an inexhaustible source of energy. Windmills have been used for grinding grain and lifting water since times immemorial. In modern time, windmills, the high-speed winds rotate the windmill, which is connected to a generator to produce electricity. Wind farms having clusters of such windmills are located in coastal regions and in mountain passes where strong and steady winds blow. Wind farms are found in Netherlands, Germany, Denmark, UK, USA and Spain are noted for their wind energy production. Nuclear power. Nuclear power is obtained from energy stored in the nuclei of atoms of naturally occurring radioactive elements like uranium and thorium. These fuels undergo nuclear fission in nuclear reactors and emit power. The greatest producers of nuclear power are USA and Europe. In India, Rajasthan and Jharkhand have large deposits of uranium. Thorium is found in large quantities in the monazite sands of Kerala. The nuclear power stations in India are located in Kalpakkam in Tamil Nadu, Tarapur in Maharashtra, Rana Pratap Sagar near Kota in Rajasthan, Narora in Uttar Pradesh and Kaiga in Karnataka. On the right side, there is figure number 3.16, which shows nuclear power station in Kalpakkam. On the left side, there is green color box, which reads Activity. Solar cooker. Take an old car tube, inflate it and keep it on a wooden platform. Paint an aluminium vessel black from outside and add 1 cup rice with 2 cups of water to it. Close the vessel with a lid and place the vessel in the inner circle of the tube. Now place a glass frame over the tube and keep the set out in the sun. After the glass frame is placed, air can neither come in nor go out, but the sun rays coming into the closed cavity enclosed by the tube get trapped and cannot escape. The temperature increases, slowly cooking the rice over a few hours. At the end of green box, the picture of sun and vessel is shown. At the bottom, there is figure number 3.17. This figure explains how the nuclear energy is made. Geothermal energy. Heat energy obtained from the earth is called geothermal energy. The temperature in the interior of the earth rises steadily as we go deeper. Sometimes this heat energy may surface itself in the form of hot springs. This heat energy can be used to generate power. Page number 33. Geothermal energy in the form of hot springs has been used for cooking, heating, and bathing for several years. USA has the world's largest geothermal power plants, followed by New Zealand, Iceland, Philippines, and Central America. In India, geothermal plants are located in Manikaran in Himachal Pradesh and Puga Valley in Ladakh. At the top right side, there is figure number 3.18, which has two parts. Part A shows geothermal energy in Manikaran. Part B shows cooking food with the help of geothermal energy. On the left side, there is figure number 3.19. In this figure, geothermal energy has been given. Where a turbine and generator are there above land, these are connected with wells, which further goes down into the groundwater. A steam and a natural crack has also been given in the diagram. Tidal energy. Energy generated from tides is called tidal energy. Tidal energy can be harnessed by building dams at narrow opening of the sea. During the high tide, the energy of the tides is used to turn the turbine installed in the dam to produce electricity. Russia, France, and the Gulf of Kutch in India have huge tidal mill farms. On the right side, there is a red box which reads, "Do you know? The first tidal energy station was built in France." At the bottom, there is figure number 3.20, which shows tidal energy. On the top of figure, it is mentioned that low tidal energy is used to produce electricity. Page number 34. Biogas. Organic waste such as dead plant and animal material, animal dung, and kitchen waste can be converted into a gaseous fuel called biogas. The organic waste is decomposed by bacteria in biogas digesters to emit biogas, which is essentially a mixture of methane and carbon dioxide. Biogas is an excellent fuel for cooking and lighting and produces huge amount of organic manure each year. Energy is everywhere, but we can see that harnessing this energy is both difficult as well as costly. Each one of us can make a difference by not wasting energy. Energy saved is energy generated. Act now and make brighter energy future. At the top left side, there is a figure 3.21, which shows biogas. Exercises. Number 1. Answer the questions given here. Number 1. Name any 3 common minerals used by you every day. Number 2. What is an ore? Where are the ores of metallic minerals generally located? Number 3. Name 2 regions rich in natural gas resources. Number 4. Which sources of energy would you suggest for? A. Rural areas. B. Coastal areas. C. Arid regions. Number 5. Give 5 ways in which you can save energy at home. Page number 35. Number 2. Tick the correct answer. Number 1. Which one of the options is not a characteristic of minerals? A. They are created by natural processes. B. They have a definite chemical composition. C. They are inexhaustible. D. Their distribution is uneven. Number 2. Which one of the options is a leading producer of copper in the world? A. Bolivia. B. Ghana. C. Chile. D. Zimbabwe. Number 3. Which one of the practices will not conserve LPG in your kitchen? A. Soaking the dal for some time before cooking it. B. Cooking food in a pressure cooker. C. Keeping the vegetables chopped before lighting the gas for cooking. D. Cooking food in an open pan kept on low flame. Number 3. Give reasons. Number 1. Environmental aspects must be carefully looked into before building huge dams. Number 2. Most industries are concentrated around coal mines. Number 3. Petroleum is referred to as black gold. Number 4. Quarrying can become a major environmental concern. Number 4. Distinguish between Number 1. Conventional and non-conventional sources of energy. Number 2. Biogas and natural gas. Number 3. Ferrous and non-ferrous minerals. Number 4. Metallic and non-metallic minerals. Number 5. Activity. Number 1. Use pictures from old magazines to show different kinds of fuels used by us in our lives and display them on your bulletin board. Number 2. Design a poster highlighting energy conservation tips you would take for your school. Number 3. Salma's class took up an action campaign to do an energy audit of their school by surveying electricity consumption. They prepared survey sheets for the students of the school. Page number 36. There is a diagram in the form of table given. Here, this table pertains to an electricity audit. There are various columns given in this table. Serial number, appliance, quantity, number being used, usage time, approximate number of working hours, quantity, number actually needed, is it switched on even when not in use, yes or no column. The name of various appliances are given here. Number 1. Fluorescent tube of 40 watts. Number 2. Incandescent bulb of 40 watts or 60 watts. Number 3. Co-impact fluorescent lamps. Number 4. Fans. Number 5. Exhaust fans. Number 6. Electric bell or buzzer. Number 7. Television. Number 8. Computers. Number 9. Air conditioners. Number 10. Refrigerators. Number 10. Oven or hot case. Number 12. Public address system. Number 13. Water pump or water cooler. Number 14. Overhead projector. Number 15. Photostat machine. Number 16. Any other. You have to fill in this table, writing how much quantity of electricity is used, the usage time, that is, the approximate number of working hours, and so on. Using the data collected during the survey, students calculated the unit consumed for 1 month and the approximate expenditure and compared it with the electricity bill of the previous month. They also calculated the approximate cost of electricity consumed by fans, lights, and other appliances not switched off. Thus, they highlighted the amount that could be saved and suggested simple energy conservation habits like: Number 1. Switching off the appliances when not in use. Number 2. Minimal usage as per requirement. Page number 37. Number 3. Maximizing the use of natural breeze and light by keeping the windows open. Number 4. Keeping the lights dust-free. Number 5. The appropriate maintenance and usage of appliances as per the given instructions. Can you add some more tips to this list? You could conduct a similar survey at home and then extend it to your apartment and make your neighbors also energy wise.